This is take home test number 5, and it's a take home, and it's the one with the calculator. Like, calculator is permitted for these multiple choice questions. Question number 1 is if f double prime x is equal x minus 1 x plus 2 whole squared x minus 4 to the power 3, then the graph of f has an inflection point. So what is inflection point? Inflection point deals with second derivative. So this is inflection point, and we are talking about second derivative. I just write second derivative like this. So how do we find inflection? Wherever concavity changes. So wherever concave up to concave down, or vice versa, down to up. So how do we do it? Derivative equals 0. We get the point of inflections, and then we make sign chart, and then we decide how the inflection points are, because the point of inflection, these are potential point of inflections, like 50% of them, 50% we are sure. But when we make a sign chart, we are 100% sure, because that's where we know concavity changes. So f double prime is already in the question. They already gave you double prime, so we're going to make this equal 0, and we're going to make each piece equal 0. And x plus 2 equals 0, and x minus 4 equals 0. So this is x equal 1, x equal negative 2, and x equal 4. I'm going to make a sign chart. This is negative 2, 1, and 4. So plug in anything here. I'll pick negative 3. When I plug in negative 3 here, negative 3 minus 1 is going to give me negative something. Negative 3 plus 2 is going to be negative 1, but since it's square, it's going to give me positive. Then I have negative 3 minus 4 is going to give me negative. So negative, positive is negative. Positive, negative, and negative is positive. So this goes positive. Next one, I'm going to erase all of this. Then we're going to go for this one, f double prime 0. Plug in 0 here. This is negative 0, that's positive 0, that's negative. Negative and negative is positive, positive is positive is positive again. So these are positives. Pick something here, f double prime 2. So plug in 2. So 2 subtract 1 is positive. 2 plus 2 is also positive. 2 subtract 4 is negative. So positive times positive is positive. Positive times negative is negative. Pick here f double prime 5. We plug in 5 here. 5 subtract 1, positive. This is positive, and this is also positive. So this one is going to go positive. Now, the question is asking which one is point of inflection. Wherever, point of inflection means wherever concavity changes. So this is concave up, this is concave up, and this is concave down, and this is concave up. So my answer is at 1, the concavity is changing, because this is positive, that's negative, concave up, concave down. So at 1, the concavity is changing, and at 4, concavity is changing from concave down to concave up. So the answer is 1 and 4, which is D. Question number 2. This one, the graph of the function f is shown, so that's original graph. For which of the following values is f prime both positive and decreasing? Positive means, f prime means a slope, a tangent slope. So they said which one is positive and decreasing. Since they said positive and decreasing, then we're going to look, this is positive. When we draw a tangent, this is positive. Like the slope is going to be positive. But what is decreasing? The decreasing, you're going to use there concave down. That would be negative. So let's try this. F prime both positive and decreasing. So I'm going to draw a tangent on these A, B, C, D dots. This is tangent negative, tangent positive, tangent negative, tangent positive. So technically I have two positives, C and E. But which one is also decreasing? This one is concave up and that one is concave down. So I would say C is my answer for that. Question number 3. The figure below shows the graph of the first derivative of the function. So that's first derivative, which means every y is a slope. How many points of inflection does f have on the interval? Point of inflection means what? Concavity changes, right? Concavity changes. Since this is f prime, how do I get the second derivative? Because point of inflection deals with second derivative. So I'm going to draw a tangent line on this f prime graph, so it will give me second derivative. So I'm going to draw tangent lines here, here. These are all positive tangent lines. These are all negative tangent lines. These are all positive tangent lines. These are all negative tangent lines. Again, positive. So we can tell how many point of inflections we should have wherever concavity changes, wherever the sign changes on like the tangent slope signs. So the sign changing over here because I'm going positive to negative. I'm going negative to positive again. I'm going positive to negative here. I'm going negative to positive here. So 1, 2, 3, 4. The answer is 4. These are how many point of inflections. So like I said, wherever concavity changes, wherever the second derivative sign changes. So second derivative, I have to draw tangent lines on this because this is the first derivative graph. Question number 4. Let f of x be polynomial function such that f4 negative 1, f4 of prime 4 is 0. If x is less than 4, then f prime is less than 0. Okay, you can read this 2 or 3 times. I'm going to draw a picture as while I'm reading all of this. They said f4 is negative 1. So 1, 2, 3, 4, and this is negative 1. So my dot is right there. f4 has a 0 slope. Like this is f function original I'm drawing, but when they said the slope is 0, which means on this I have to have a horizontal tangent. That's what it means. X is less than 4. Less than 4, I'm talking, this is 4 actually. So less than 4 is this side. Then f prime is less than 0, which means I'm going to have all negative slopes. Like I just keep the graph like this. So this is negative slope. When I draw tangent lines up here, they're going to have a negative slopes. If x is greater than 4, greater means all of these sides, f prime is less than 0 again. So I'm on negative slope again. So probably my graph goes like this. So these are again tangent negative slopes. Like you can tell when I draw negative, like when I draw tangent lines here, they are all negatives. So that's what it means. These are all tangent lines negative, greater than 4 and less than 4. And at f prime 4, I have a 0 tangent, which means it's a horizontal line. So this is the graph, that's how it looks. What can be said about the point 4, negative 1? This one is, for example, this one, since I'm looking at it, when I draw a tangent lines up here, I can see negative 4, the slope is 0 here. That's what it means. The slope is 0. When I draw a tangent line, it's 0. I can say it's not a relative maximum because I'm not changing any signs from positive, negative, negative, positive. So there is no extrema here because these are all negative slopes. So that one doesn't work. The point is a critical point, but not an extrema. Yeah, that could be. Point of critical point means what? What is critical point definition? When the derivative is equal 0 or undefined. So in this case, the derivative is 0. So I can say it's a critical point, but I don't have extrema here because I'm not changing any sign positive, negative, negative, positive. This one is not okay either. Relative minimum, it's not. A point of inflection, no. I mean, it's a first derivative, not there. So the answer is B. Question number 5. Let f be the function with a derivative thus. How many relative maximum does f have on the interval 2 to 4? So since this is a calculator based question, I am going to graph this. This is a derivative, and every y value is a slope. So I'm going to see where the graph is going positive to negative on the x-axis, and the window is supposed to be 2, 4. So I'm going to go to the calculator, add a graph, and the question is sine, and let me check, what is it? Sine x squared plus 1. So this is x squared plus 1, and hit enter. Now this is the graph. That's how it looks. I'm going to move this right there. And now the window is supposed to be set to 2 to 4. So window, and I'm going to hit that. And this is 2. That one is 4. And click OK. Now this is what my F prime graph. So like I said, we're going to look where the going positive to, I'm sorry, that's negative, positive to negative, like that's where maximum supposed to be. And since this is y F prime, so I just don't have to do anything else. Just look for the graph where it changes from positive to negative. Now over here it changes negative to positive, so that's not it. That's positive to negative, which means 1. This one is positive to negative, that's 2. This one is negative to positive, so only 2 that I have. I think I have 2 point relative maximum right here and right here. These are 2 relative maximum, so we can say 2. Question number 6. The first derivative of the function is defined by this for 0, 2. On what interval is f decreasing? This is f prime. Decreasing means when we have, f prime means when I graph this, that will be every y slope, right? So if they're asking decreasing, I'm going to look for every negative y value of every negative y values, and I'm going to pick all of those, and it has to be between 0 and 2. So I'm going to go back to my calculator, and let's see the tab. We go to that tab and I delete this. Is it sine? I forgot the number. Sine x cube sine. This is x to the power 3, and move the cursor, and it's minus x. I think it's minus x. I'll check back. Yes, it's minus x. In the window, let's enter. This window is like 2 to 4, but actually we need a window 0 to 2. So I'm going to go and change the window 0 to 2. That's 0. And I got that one, which is 2. And enter. So this is what I got for the graph. And they're asking me, the question is, where the f is decreasing. So do you see all these numbers? So I'm gonna find where it's decreasing. So we're gonna go back there. Decreasing means all the negative y values. So from here to here, these are all negative y values. From here to here, these are all negative y values. So let's go to menu, and we're gonna use that graph trace. So I can move my graph over here to the first one. The first one is 0. I can tell that's a 0. But what is this one? It's 1. So 0 to 1, that's negative y values, which means that's decreasing because this is f prime graph. Then I'm going to go and check the other one. Right here where it says 0, that's 1.69. So I have 0 to 1 and 1.69, 1, and then go to the next one where it's right here another 0, that's 2.025. So the answer is 0 to 1, 1.69, 1 to 2. So the answer is D. Because that was f prime graph, all we have to look for the negative y values, that's decreasing. Question number 7. Question number 7 says, for all x in the closed interval 2 to 5, the function f has a positive first derivative, which means tangent slope supposed to be positive, and a negative second derivative, which means concave down. Which of the following could be a table of values for f? So there are 2 different ways we can find this question. First, you can just literally graph it and see if the tangent lines, you draw tangent lines because this is original graph. So you draw tangent lines, and if the lines are positive and concave down at the same time, then that will be the answer. And there is another way that which I'm going to show, but let's graph first. So 2 to 7, this is 2, that's 7. Then I have 3, 9, that's 3, 7, 8, 9. Oh, it's not supposed to be there. 9 right there, 3, 9. So this is 9. Then I have 4 and 12. This is 4, 9, 10, 11, 12. That's 12. Then I have 5 and 16. That's 5. And 12, 13, 14, 15, 16. So this one looks like concave up, and it's every tangent line is, when I draw tangent on these dots, it's going to be positive slopes. Like every tangent is positive, but it's concave up, so it's not concave down. So A is not my choice, so I'm going to erase that. Now I'm going to draw another one, which is B. It's 2 7, that's 2 1 2 3 4 5 6 7 right there. Then I have 3 11, that's 3, and 11 is 9 10 and 11 right there. And then I have 4 and 14, that's 4 and 14, 12 13 14. And then I have 5 and 16, that's 5 and 16, this is that's 12. What was that? That's 14. So this is going to be 15 and 16. So this one looks like this. So this one looks like a positive slopes. When I draw tangent lines, it's positive, and it looks like a concave down because it's going to go like this. So I'm going to keep this in mind, but I'm going to draw the next one, C, and see if that one would work for us. And I'm going to draw D2 to see which one is my answer. So let's try C. 2 16, that's 2, and 9 10 11 12 13 14 15 16, 2 16, 3 12, that's 3, and 12 is right there. And then you have 4 9, this is 4, and this is 9. 5 and 7, that's 5, and that's 7. It's look like a straight line to me, like this. And when I draw tangent lines over here, they are all negatives. Like draw tangent, they are negatives. So this one is not my choice. So let's try D. We're gonna try D. Okay, let's see. The first one is 2 16. 2 and 12 13 14 15 and 16, that's 16. Then I have 3 14, that's 3, and 12 13 14. 4 11, that's 4, and 9 10 11. And this is 5 and 7, 5 and 7. This one is also negative slopes. Look, negative slopes. So I don't want to see the concave down or up because it's negative slope. The first one doesn't make sense. So this one is not my answer. So the choice is B. Now, another way that I said I'm going to show you guys, you have to find the derivative. For example, the first secant slope. So 9 subtract 7, 7, 8, 9, that's 2. 12 subtract 9, 9, 10, 11, 12, 16 subtract 12 is also 2. So you see the derivative is constant. It's not, it is, first derivative is positive, like the tangent, all the slopes are becoming positive. But they said the second derivative is supposed to be negative. When I do the second one, like 2 subtract 2 is 0, 2 subtract 2 is 0. It's not a negative second derivative. So it's not concave down, it's not negative. So this one didn't work. If I try this one, 11 subtract, you have to make sure that the second number subtract the first one. So 11 subtract 7, 7, 8, 9, 10, 11, that's 4. Then I'm going to go 14, subtract 11 is 3, and 16 subtract 14 is 2. So this is positive slopes, all of them, and second derivative negative. So let's try the negative. 3 subtract 4 is going to give me negative 1. 2 subtract 3 is going to give me negative. So yes, the second derivative I'm getting negative. The first derivative is positive. Done. Now let's try these. 12 subtract 16 is negative 4. And you know the first derivative is supposed to be positive, not negative. So this one is just canceled the first time. We do the same thing here. 14 subtract 16, it's going to give me negative 2. So no, the first derivative is supposed to be positive. So that's another way to do it. Okay. Now, this is free response question number 1. Pictured above is the graph of f prime. So this is f prime graph, which means every y value is a slope. We always write that. The first derivative of twice differentiable function f of x on the interval 0 to 10, such that f of 2 is equal 8.843, this is y value, that's an x. The equation of f prime is defined by that. Answer the question that follows. And since it's a calculator-based questions, we can also use a calculator and graph this on the calculator to see exact values wherever we need it. So let's try part A. On the interval 5.3 and 6.7 is the graph of f of x concave up or concave down. These concave up and down works with second derivative. So if it's first derivative and the question is asking second derivative, then I have to just draw tangent lines over there. So I'm going to draw tangent lines here. These are positives. Draw tangent lines over here. These are all negatives. Tangent lines over here. These are all positives. These are all negatives. So I know all of that. Now let's see if between 5.3 and 6.7. So this is, I'm going to say, let's see that. This is 5.3, I think, over here, like I can draw a line. And 6.7 could be over here somewhere. So they are talking about only this portion. So this portion, when I draw a tangent line, these are all positive. So it means they are concave up. And how do we explain that? And this is justify your reasoning. The graph of f of x, I'm going to pick the words from the question. The f of x graph is concave up, on the intervals, 5.3 x 6.7, because f double prime x is greater than 0. Okay, that's the reasoning. And f prime x and f prime x is increasing, because you can tell it's a positive, like it's increasing. Okay, so that's what the point is. The f prime x is increasing on the interval, f double prime is greater than 0, and it's concave up. So this is part A. Let's do part B. For what values of x does the graph of f of x have a relative maximum? Relative maximum means that I am going positive to negative. And since this is f prime graph, all the y values, which y values going positive to negative? So if you guys check, at this point it's going positive to negative, and at this point it's going positive to negative. Like I'm going positive to negative, positive to negative. So these are the two I have for maximum, but I exactly don't know what points are there, what y values are there, what exactly the x, in essence they're asking the intervals, so technically x values. So I am looking for the x value, but what exactly these x values? So that's why I want to graph that and see, and I'm going to trace the graph and see which one works. So my equation is 4xe, I'm going to go there. It's 4x e power is negative x over 3, and then move the cursor, and that one is sine x, so that's sine in x. We enter, that's f prime graph. So I'm gonna go and change the menu windows, and I'm gonna go 0 to 10. So that's 0. There you go. That's 0 to 10. Now, since I'm doing the graph and I know this one is maximum and I know that one is maximum, so I'm going to move my cursor here and see what exactly that point is. This one is 3.142, and the next one is, that one is 9.425. So I'm going to go back and I'm going to say question B. The B said f of x has a relative maximum on the maximum at x equal 3.142 in x equal 9.425, because f prime x changes signs from positive to negative. Okay, part C. On the interval 0 to 10, what values of x does the graph f have a point of inflection? Point of inflection deals with a second derivative. That's a second derivative. So if that's a second derivative, it means I'm considering my tangent lines. So where is point of inflection? This is all positive, that's all negative. So my point of inflection is right there. This is negative 2 positive tangent lines, point of inflection, point of inflection. So technically I have 3 point of inflections, and since they are asking for the x values, again I'm going to go to my graph and figure it out that one. So my point of inflections are, it's right there on the top, so I'm going to move the cursor so I can see my point of inflections. So I have right there, that's point of inflection, which is 1.792, and I said like I have 3 of those, so I have one down there. This one is 4.597. Next one is right there. That's your 7.654. And remember, I drew, this is f prime graph, so I drew tangent lines over here. I drew tangent lines here. So these are all positive tangent. These are all negative tangent. So concavity is changing and changing at this point. So that's how we got those points up here. So I'm going to say on the interval, I'm going to pick the whole question, 0 to 10 at x equal 1.792 and 4.5, that's comma, 4.597 and 7.654. The graph of f of x have a point of inflection. Point of inflection. Because f double prime x changes signs. There. Question part D of this free response question. It says approximate the value of f 2.4 using the equation of the tangent line. So when they use the word equation, it means y minus y1 equal mx minus x1. Tangent means derivative. Drawn to the graph of f at x equal 2. Approximate the value of f. This also means you have to get the y minus y1 equal mx minus x1. If you guys check your memorizing page, that's what it is. And then after you get the mx1 and y1, you plug in this x as a 2.4, and that will be your approximation value. So we are going to get the y e minus y1 equal mx minus x1 first. I already have a x, which is 2. I don't know the slope. I already have a y1 because it was given in the question right there. 2 is equal 8.843. So y minus 8.843. How do I get the slope? Since the graph is already f prime, so every y value is a slope. So what is the y value at 2? This is the value that we need to figure it out. So that's why I'm going to go and get the graph. This is the graph from 0 to 10 for the equation right there. So I'm going to go to menu. I'm going to trace, and I can do graph trace. So I need exactly a value where the 2, x is equal to, what is that y value? So if you guys check, my mark right there is already on 2.1, which is equal 3.6. So the slope is, if we can move this to just a little bit more to make it 2, there you go, that's exactly 2. I used this left side, and it went to 2, and the y value is 3.734. So I'm going to go back there, and I'm going to say the slope is 3.7 3.73. I'm going to round it up to 5 because every y value is a slope, so all I needed a y value at exactly 2. So this is my equation. Now I'm going to plug in that 2.4 for x. So I get y minus 8.843 equal 3.735, and then I got 2.4 minus 2 to get the exact approximation. When you solve this, I'm going to get y equal 10.337. So that's the approximation when you plug in 2.4. Now they said, is this approximation over or under of the actual value? Give a reason for your answer. So since x is equal to when x is equal to f prime is decreasing, which means f double prime x is less than 0. So why would I say that? If you guys pay attention, this is my graph and I'm talking about at 2. So when I draw a tangent line at 2, that's decreasing, which means it's concave down. So if it's concave down, which is concave down, which means f of x is concave down. If it's concave down, then the tangent line, we're going to pick this wording from here, then the tangent line to the graph f at x equal to is over approximation of the actual value of f 2.4. Because if it's concave down like this, then it's over approximation. And how I decided that, I drew a tangent line because concavity deals with a second derivative. So at x equal to, when you draw a tangent line, it's going to be negative. So that tangent line means it's negative, then it's concave down. Now the next part is the take-home test. This is part 2, where the calculator is not allowed. Question number 8. If for all real numbers x, f prime x is greater than 0, which means the tangent slopes is positive. F double prime is greater than 0, which means it's concave up. Which of the following curves could be part of the graph of f? So look for tangent slope positive. So if I draw tangent lines here, this is negative, and if I draw up here, they are all negative, so this one doesn't work. If I draw tangent lines here, they are all positives, and it's concave down, so this one doesn't work either because I'm looking for concave up and tangent slopes. So if I draw here, these are tangent lines positive and it's concave up. If I draw tangent lines here, they are negative and concave up, so C is the answer. Question number 9. Let g be the function given by g of x square e to the power kx, where k is constant. For what value of k does g have a critical point? Critical point at x equal 2 over 3. So what is critical point? Critical point is when you take a derivative, you make it equal 0 and you get critical point. So, and then you make a sign chart, but right now we are talking about critical point. So I'm going to do all of this, and then I'm going to plug in x, which is 2 over 3. This will give me k. So let's take a derivative of this, and this is a product rule. This is f in g. So just from the word critical point, I know what I'm going to do and how to solve this question. So let's take a product rule. Product rule says f prime times g plus f times g prime. Let's take a derivative of f, which is 2x. I'm going to go g prime x equal. Keep the g as it is, ekx, plus keep the f as it is. Take the derivative of g, which is ekx, times the derivative of the top, which is going to be just a k because k is a constant. So this is what I got so far from the derivative. Now we're going to make this equal 0, and then I'm going to get critical points. So before I get the critical points, ekx and ekx are common factors. So I'm left with, I think x ekx is common factor. So I'm left with 2 plus x k equals 0. So make this equal 0 and make this equal 0. So I'm going to make this one equal 0, and I have to plug in g prime x. I have to plug in 2/3. So g prime 2/3. So I got 2/3 for x, ek 2/3, and again 2 plus 2/3 k equals 0. So now if I make this equal 0 and make this equal 0 separately, and that's what we do in critical points, 2/3 equals 0. So I divide 2/3 both sides. both sides. I'm left with ek 2/3 equals 0. To get rid of e, I'm going to do ln. Now, ln e disappear. I'm left with k 2/3, but ln 0 is undefined. It's an error. We should remember this. ln 1 is equal 0, but ln 0 is error, so we can't do this. Now we're going to make this equal 0. 2 plus 2/3 k equals 0, and that way I can get that k by itself. It's going to be -2, divide 2/3 and divide 2/3. They cancel out. I'm left with k equal -2 times, you do the reciprocal, 3/2. So 2 and 2 cancel out. I'm left with -3. So k is equal -3. So the answer for question number 9 is A. And just from this critical point, I figured out how to do this question. So I took a derivative, I made it equal 0, and I solved the question all the way. Then make each part equal 0 like we usually do. Question number 10. Picture to the right is the graph of f prime. If this is the graph of f prime, it means every y value is a slope. The first derivative. For how many values does the graph have horizontal tangent where the y is equal 0? Horizontal tangent means when the derivative is equal 0. Since the derivative, every y value is a slope, then I'm looking for technically y is equal 0, but not relative max and min. So my horizontal, y equals 0. This is a horizontal tangent because, y is equal 0. This is a horizontal tangent because y is equal 0. This is a horizontal tangent because y is equal 0, and this is a horizontal tangent. But they said pick the horizontal tangent that is not a relative max or min. A relative max and min means when it crosses the x-axis. Like for example, it crosses here, so that's minimum. This is a horizontal tangent, but it's also minimum, relative minimum. This is relative maximum, and it also horizontal tangent. But these 2 points is not even crossing the x-axis. They just touch and then go back. So I have 2 horizontal tangents, but not relative maximum and minimum. So it's D. Question number 10 is D. 11. The graph of twice differentiable function f with the relative maximum -1, 2 is shown to the right. Which of the following inequality statement is true? So this is, I know this is f of x function. So they said, what is f of, since they're asking in order, like which f -1, so we have to figure it out each one of those. So it's really easy. You guys have to just pay attention. Find f -1. This is -1 and this is 2. When x is -1, the y value is 2, and this is f original, okay? So this means that's positive 2. So now wherever I see f negative 1, that means that's 2. F negative 1, that's 2. F negative 1, that's 2. Okay, done. Now, what is f prime negative 1? So f prime negative 1 means I have to draw a tangent line. So I'm going to draw a tangent line at negative 1, and you can tell the negative 1 tangent line is 0. So f prime negative 1 is 0, f prime negative 1 is 0, 0, and 0. Okay, done. Now, what is f double prime negative 1? Double prime deals with concavity. So at negative 1, it's concave down. If it's concave down, you can tell it's concave down. If it's down, then it means it's negative. F double prime, negative 1 is negative. So that's negative, and that's negative. Now check how it goes. 2 is less than 0. That's wrong. That's not how it goes. The statement is incorrect. Negative is less than 0, and 0 is less than 2. Yeah, makes sense. 2 less than negative. No. 0 is less than 2, and 2 is less than negative. No. So the answer is B. Question number 12. The graph of second derivative of the function is given below. Which of the following is true or true? F double prime means it's concave up and concave down. Concave up, concave down deals with that, and also point of inflection. Concave up means it's above x-axis I'm talking about. Concave down means below x-axis because it's double prime graph already. So the graph of f of x has a point of inflection at x equal negative 1. This is negative 1. And since I'm going concave up to concave down to up, then it means for this it's true. The graph has a point of inflection because, that's above x-axis, that's below x-axis. It means it changes here. So that's true. The graph of f is concave down on the interval negative 1 to 3. They said it's concave down from negative 1 to 3. Yes, because, it's concave down means below x-axis. So yes, that's true. If you guys check my chart, and you can check the concave up and down for the f double prime, it's below and above x-axis. The graph of f prime is increasing at x equal 2. X equal 2, they said it's increasing. It's double prime, so I don't know if it's increasing or decreasing. So 1 and 2 are correct. It's C. Question number 13. If g is a differentiable function such that g of x is greater than 0 for all real numbers x, and f prime is, which of the following is true? They said f prime. So relative maximum, minimum, relative maximum, and minimum, all of that means I have to take a derivative, make it equal 0, critical points in sign chart. So I'm gonna go for derivative this is already a derivative, so I'm gonna make it equal 0. So if I make x square minus 4 equals 0, it's gonna give me x square equal 4 and x is equal positive negative 2. So this is my positive negative 2. That's my critical points, and I already know g of x. If I make this equal 0, then it means they already said it's supposed to be greater than 0, which means it's supposed to be positive. So this is negative 2, that's positive 2. Pick something here for f prime, negative 3. If I plug in negative 3 here, negative 3 square is going to give me 9. 9 subtract 4 is positive, and g of x is already positive. So positive and positive is positive. Now pick something here, 0. It's single prime. So if I plug in 0 here, that's negative, and that's negative, and that's positive, which will give me negative. So this is negative. Next one is f prime 3. If I plug in 3 here, so again it's going to give me positive. So I know at negative 2 I have from positive to negative, that's maximum. From negative to positive, that's minimum. So at 2 I have minimum, and at negative 2 I have maximum. F has a relative maximum at negative 2 and relative minimum at x equal 2. It's A. The rest of them is, if you guys read it, it's not true. 14. The graph of f double prime, the second derivative is shown to the right for negative 2 to 4. What are the intervals on which the graph of f is concave up? Again, this is double prime. It deals with concave up and down, which means above x-axis and below x-axis. And point of inflection deals with this for the double prime. So above x-axis, they said concave up. So it means I'm talking about above x-axis. So I'm going negative 1 to 1. This is above x-axis, and 3 to infinity or somewhere. So let's try negative 2 and 1. Negative 2 and negative 1, that's below x-axis. It's not concave up, it's concave down. So that one not true. Negative 1 to 1, that's true. 1 and 3, 1 and 3, no, that's concave down. Negative 2 and negative 1, no, that's concave down. They're asking only concave up. So the answer for 14 is B. They didn't mention 3 to infinity, but I mean, we know that's the only one true. This is the free response question, and since this is non-calculator section, so free response, we are not going to use a calculator. So these are all x values, these are all y values like f of x, these are f prime like tangent slopes. F be a differentiable function such that f double prime greater than 0. If f double prime greater than 0, it means it's concave up. For negative 1.5, 1.5, the table above shows values of f of x, f prime x for selected values of x on the closed interval negative 1.5 to 1.5. Part A, at what value of x does the graph of f of x have a relative minimum? Relative minimum means negative to positive. Give one reason based on the values of f of x and one reason based on the f prime. So where I'm going negative to positive. Negative to positive, relative minimum, we know that we take a derivative, we make it equal 0, we get critical points, and we make sign chart. So the derivative is already here. So what is the critical points? Critical points where the derivative is 0 or undefined. So this is a derivative, and that's 0. So at what x value derivative is 0? At 0. So this is my, for example, if I make a sign chart for f prime x, then 0 is my critical point. If I pick something here, on the left side of 0, these are all negatives. So these are all negative values. On the right side of 0, these are all positives. So 0 is my relative minimum because I'm going negative to positive. That's a sign chart. But you guys can tell wherever the derivative is equal 0, that x value is the critical point. So I'm going to say f of x has a relative minimum at x equal 0. Now they said give one reason based on the values of f of x. You can say the value of f of x because the f of x is decreasing from negative 1.5 to 0. These are all values that are decreasing. So f of x is decreasing on the interval negative 1.5 to 0 and increases up here from 0 to 1.5 and increases on the interval 0 to 1.5. Another reason based on f prime. Based on f prime, you can tell changes signs from negative to positive. F prime x is changing signs from negative to positive. Now, if you check every negative values, when the negative values goes higher, like 1, 4, 6, 7, then it means it's getting smaller and smaller. So -7 is smaller than -1. So that's why I said f of x is decreasing from -1.5 to 0. These are all decreasing. These are all decreasing. And it increases because -7 is smaller and the other one is -1 is bigger. Part B of the free response question, this one without the calculator. It says that using the values of either f of x or f prime x, explain why the values in the table confirm the assertion f double prime is greater than 0. We already know that, and if you guys go check in on your memorizing page, which is right here. So I'm gonna show you memorizing right here, this one. If f double prime is greater than 0, then what is the assertion? F prime is increasing. And what is the assertion for f of x? It's concave up. So this is the reasoning for both of them. So you go back and check part B right there. You can say f confirm the assertion f double prime 0 if f double prime x is greater than 0, then the graph of f prime x must be increasing. Must be increasing. So we can tell f prime x is increasing. Like you start with -7 and go all the way to +7, so it is increasing. So that's why f double prime is greater than 0. So the values of f prime x are always increasing on the interval -1.5 to 1.5. And you can tell from -1.5 to 1.5, all the f prime x is increasing. Okay, so part C, write an equation of the tangent line to the graph of f when x is equal to -1 and use the equation of the tangent line to approximate the value of f -1.1. Approximate the value. Again, we need y minus y1 equal mx minus x1, and when we get y1, m, and x1, we plug in 1.1, -1.1 for this x. And that would be our approximation. Tangent means a derivative. Equation means the same thing. Y minus y1 equal mx minus x1. So we can get 1 point for this to give them equation, another point for approximation, and technically you don't have to do a lot. So I have y minus y1 equal mx minus x1 for -1. So I already know my x is -1, so minus and this negative is going to turn positive. I need a slope and I need a y value. So how would I get that y value or the slope? The y value, let's see if we can have anything. This is -1, the y value is -4, and the slope is -5. Do you see everything is already given in the table? That's -1, that's the y value, and that's the slope, which is f prime. So I already have everything. These are easy points to get. -4 means +4, and this is -5. So that's my equation, and I have to plug in that -1.1 for that x, y plus 4, and it will give me y equal, when you solve this, you're gonna get y equal -3.5, and that was the answer. And actually that one was the answer, so you get 2 points for this. Part D, is the approximation in part C for -1.1 is under, over of the actual value justify your answer. So we're gonna see if -1 is at -1, what's going on with the f double prime. Is it concave up or concave down? So since I can tell this is -1 and this is f prime. If f prime is increasing, then f double prime is supposed to be concave up. on the interval negative 1.5 to 1.5. So if it's concave up, and we already talked about it, that it's increasing and f double prime is greater than 0, so it means it's concave up. The let's see, the approximation, it's concave up, so a concave up means it's under approximation. So I'm gonna say the approximation of f negative 1.1 is an under approximation because f double prime x is greater than 0 and is concave up on negative 1.5 to 1.5. So this question has 2 points where you say under and where you give them the reasoning. So you got 2 points right there. This is another question. This is the last free response question on the test, on the take-home test. The graph of f prime is given on the closed interval negative 10 to 10. F prime has a relative extrema at negative 3, 2, and 6. Use the graph to answer the question. They said relative extrema, it means it could be negative relative maximum or minimum. When we say f prime graph, then it means every y value is a slope. So what interval the graph of f of x is increasing? F of x is always increasing, which means every y value is a slope technically, so I'm looking for positive y values. So from negative 7 to negative 1 and 4 to 8, these are all my positive y values. So I'm gonna say f of x, I'm gonna pick the wording from the question. F of x is increasing on the intervals negative 7, negative 1, and 4 to 8 because f prime x is greater than 0 because it's all positive. Now part B said at what values of x does the graph have a relative minimum? Relative minimum means when we go negative to positive, and since every y value is a slope, all I have to look for the graph where it's going or passing the x-axis from negative to positive. So this is where I'm going negative to positive, so it's negative 7. This is where I'm going negative to positive at 4. So negative 7 and 4 is my relative minimum. So I'm gonna say f of, again, pick the question, the wording from the question. F of x have relative minimums at x equal negative 7, at x equal negative 7, and x equal 4, because f prime x changes from negative to positive. Next, part C said on what interval is the graph of f was concave up? Concave up deals with second derivative, and we can say concave up when double prime is greater than 0. So how do I get double prime from the f prime? You have to draw tangent lines. Tangent lines, like I'm taking a slope of a slope. So tangent line on this f prime. So if I take a tangent line over here, these are all positive tangent lines. If I take tangent lines here, these are all negative slopes. If I take tangent lines here, these are all positives. These are all negative tangent lines. So where it's concave up? From negative infinity to negative 3. So I'm going to write f of x is concave up on from the intervals negative infinity to negative infinity to negative 3 and 2 to, I think it's 2, no, 4 to, it's 2 to 6, like this one over here, and this is concave up from 2 to 6. So that one is 2 to 6 because f double prime max is greater than 0. Determine all the values x at which the f of x has a point of inflection. Again, second derivative, and wherever concavity changes. So again, I already drew tangent slopes right there. These are positive and negative and positive and negative. So I'm going to say where the point of inflection, wherever this concavity changes, like this is concave up, this is concave down, concave up, concave down. So concavity changes over here, which is negative 3. Concavity changes here, which is 2. Concavity changes here, which is 6. So it's negative 3, 2, and 6. So the f of x have point of inflections at x equal negative 3, negative 3, 2, and 6. Negative 3, x equal negative 2, positive 2, and x equals 6. Because f double prime x, changes sign. Okay. So that's all we have. If you guys have any questions, please comment below. I will try my best to answer it.